Hi everyone, so today we will talk about cryptography and ciphers. More specifically, we will discuss the Caesar cipher and how it can be implemented using JavaScript. So cryptography is a way of securing information, and ciphers can be viewed as virtual locks which have keys. One of the earliest known and in fact easiest and simplest ciphers is the Caesar cipher, which has been used by Julius Caesar, who apparently used this as a way of communicating with his generals in more secure way. So what basically Caesar cipher does is that it just shifts every single letter by the number of shifts that we give it to. So let's say if the shift is 1, then every single letter in the alphabet will have a shift of 1, which will be, in the case of A, it will become B, and in the case of B, it will become C, and this will continue in the same way for all of the letters that we give it. So let's see how we can implement this cipher using JavaScript. First of all, we need to create a function which will take two arguments. First one will be string, which will be our text that we hope to encrypt, and the second one will be number of shifts and the amount of shift that it will have. So we'll need our function to return us the result, which will be the encrypted version of our information. So for that we need a for loop which will start at index of 0, and if the index is smaller than the string length, which again string is the information or the text that we give our function to, the index will increment. So we'll have several cases in case of this function. First of all, we need to know about character code add function, which is basically about the fact that every single symbol and letter that we can think of has been already standardized and numbered. And in case of letters, we have 26 letters, and but we have uppercase letters and lowercase letters, which are obviously different. And in case of uppercase letters, we have them numbered from 65 to 90, and in case of lowercase letters, we have from 97 to 122. So if we think of the hello world example, we can see that H is 72, which is an uppercase letter and is from 65 to 90, and E is 101, which is a lowercase letter and is numbered from 97 to 101. So this is basically what char code add function does. And if we look at our code, the first case is that if it's a uppercase letter, then it will take it, and what it will do is that it will bring it to the initial state by taking out 65, and then it will add the shift that we already give it, and then it will take the mode of 26, because maybe we are adding, maybe the shift is more than 26, let's say 29, then we'll take the mode which will be adding the shift of 3, which is the same as 29, and then it will add to it 65, which is the initial state. So the second case is the case if we have lowercase letters from 97 to 120, and this does the same to it. So we are taking out 97 and we are adding the shift, and we are also taking the mode of 26 of this whole thing, because maybe we are giving a shift of bigger number than 26, and we are adding 97 to just have it on the initial state. And the last case is the case of having a space, and in Unicode characters list, a space is numbered as 32. So if it's 32, we're just returning a space for the space, and we'll have the result, which will be the string and the already the code encrypted version of the code, and we'll want to return the result. So we'll want to look at this example, and we can just console log Caesar cipher, and let's say Caesar having 1, and we are giving it shift of 21. In order for us to be able to look at this example, we'll just create a basic HTML file. So let's say okay, so the script source is the Caesar cipher JS, which we just created, and we can look at our index.html file here. So we go to the console, we'll see the following, which is actually the encrypted version of Caesar having fun. So I hope that you enjoyed this video and learned more about cryptography in Caesar Cipher, which is a really cool way of encrypting information and communicating in a more secure way. Thank you.
Look what you got.